Yeah, maybe I'll be what do you call it, narcissistic and keep it on myself. I think that I do have control over that. Anyway, so we're gonna start off with, as discussed, a quick review. I think of lesson 3, unless you want to do general Python stuff. Emma, what was the last homework assignment you completed?
Oh gosh. For this class, I'm not sure. I started work on, did not get a good handle on the data. Let's see, like the data sifting process for zip codes.
Zip codes. Okay.
Um,
And then
yeah.
you finished what number am I thinking of, right?
What number are you thinking of? Yes, I finished that.
And you haven't done adventure game, is that right?
I have not done adventure game. I've
Okay.
been very much behind, focusing on
Okay.
getting my foot in the door at UST,
Okay.
and and the move and all that stuff.
Okay, no
And
problem.
yeah,
So
I feel rather guilty for that.
that's okay.
Um,
Don't worry about it.
hmm,
What matters is you're back here. You're getting back in the groove. So what I'm going to suggest is that we do kind of like a speed round or a recap of the material from last week, the adventure game. And I think Andre can ask a couple questions that he's having about that material, and then Emma can get her first exposure. Does that sound like a plan for you guys? Yeah.
hmm, sounds good.
So just quickly, lesson 3, that was last lesson, was about CSV and higher order functions, and the project that we made was an adventure game uh, using lesson 3. Oh, by the way, Emma, I don't know if you've seen this. This
Hmm.
website, this is where I'm uploading all the class materials to.
Oh, it's great.
So you're gonna want to bookmark that
Hmm.
ASAP because you'll get the
Hmm.
link to all the slides and links to the videos, links to homework solutions, homework assignments. I'm gonna try to
Got
just
it.
dump everything out there.
Okay.
Okay. So then
Okay.
I'm gonna change my screen share to go to my whole monitor so I can jump into the terminal for you guys. Go. So yeah, just a quick preview for you, Emma, and a recap for Andre. For lesson 3, let's see here. For lesson 3, the goal is to create an adventure game, and it plays.
Hmm.
Oh, is this not working right? I might have screwed up my rooms. All right, well, I'm not going to troubleshoot this on air, but I've got a an adventure game put together here, powered by a CSV file. So, Emma, have you ever worked with CSV before?
No, not in any serious capacity. I understand the basic idea behind it in that it's a very long, basically a very long string of strings separated by commas.
Yeah.
And the way it can be parsed is if you structure a program such that it recognizes the commas or whatever character is used to separate values, then you can
Yep.
generate a number of data structures from that.
That's right. That's exactly right. So in our case, we have an adventure game CSV or
Hmm.
adventure game that's powered by CSV, and the idea being that we have for each room the name of the room, the exits. Here, I'll zoom in a little bit.
Mm.
The name of the
Um,
room, the exits from the room,
mm.
the description of the room. And you mentioned this idea of different data structures. I'm sorry, it's kind of fading in and out a little bit. I think that's my Zoom taking a while to enact. But you see this first row is dedicated to the headers. That's like describing what's in each column. And then, so we have locker room, and within locker room we have the string battle room atrium. These are the different rooms we can go to from the locker room. And then you've got this third thing, which is the description of what you see as a player in that room. So what's neat about this is that you can kind of define not only the room in the description, but also this kind of list of exits, this list of places you can go to from there.
Hmm.
So, so it's all data-driven design, and you should be able to make that work based on the sample that I've given you.
Got it.
The key thing, have you worked with a dictionary before, Emma?
Not really. I
Not really?
understand the basic idea. I understand that there are a number of values. There's what is it, a key and a definition.
That's right.
Um, and let's see. Uh, there may be multiple instances of any given definition, but there are exactly one key for every key
One value for
in the
every key.
dictionary.
Yeah.
Yeah.
Great. Yeah, and so yeah, I gave you guys an example about how to take a string and split it into a list of strings. You can see that on your own. Again, here's some example of airport data. This is a CSV file of the airports of the world. I'm illustrating that you can open up CSV folder files in like Excel, OpenOffice, Google Sheets. It's a very handy way to edit the files.
Mm.
Then higher order functions. Again, I don't think we can spend too much time on this on air before we get to the next
Okay.
lesson. But the basic idea, what's that?
I understand the gist of a higher order function. I've
Uh-huh.
had very limited exposure through Udacity.
Yeah.
But I can't say I have an intuition for designing them yet.
Yeah, no, I think the intuition is the hardest part, but as long as you can understand in an abstract way that a function can be treated as data the same way that a number can, the same way that a string can, right? So here, this idea of perform on row, we pass f around as a function the same way that we would pass around a number, and we apply this function in the for loop. And I think it's just kind of interesting to see that, oh, we're given a function as a parameter, and now we're just using it without even knowing what function this is. We're saying, take this function f and then run it on each of these rows. Do you see that?
Let's see. Define for rows, f and rows, for row and rows, is f for row. Okay, so where f is another function?
Where f is some function that we've been passed, yeah.
Okay. Great. Define output, define print, for row, output indicators. Let's see, so, forgive me for being rather distracted. I've tried to, I've been on my work laptop for the past few hours in my room, and I'm trying to capture the sunlight. I didn't really plan my time very well.
Sure, no problem.
So I'm just looking at my mobile screen. What is the second part? Define output and define print.
Right. So
what's going on there?
So you worked through the hardest part when you looked at the perform on row with the f of row. That was the most difficult part. If the bottom half of the screen is output through perform on row, from output on down, that's us just invoking this perform on row function, right? So if you look at the very bottom line, perform on row, output stators, what we're doing is we're handing the function output, and we're in this data structure skaters, which I think was over here, right, where we have these different rollerbladers that we pass in as the rows, and the output is just the thing that we're running on all the rows. And I found it was hard to pass in print as the function f, so output here is just kind of like a wrapper around print, if that makes sense.
Okay, I think I have some sense for it.
Yeah, so basically,
perfect,
it's like the same as saying for row and rows print row. You know, it's the same kind of thing. But what's nice is that we can just pass in whatever action. We could say, you know, instead of just printing it out, maybe we have another function that takes each row and saves it to disk, or uploads it to a server somewhere. And I just wanted to illustrate that higher order functions are a way to kind of separate the data versus the action that you take on it. And this can be very powerful. Andre, just quick check. How's your lunch going?
I'm good.
Good? Are you still eating? Done eating?
I'm good.
Meaning done eating?
I'm done eating. I'm sorry.
Okay. Do you have any questions on lesson 3 for us to go over lesson 4?
Everything's good for me.
Yeah. Yeah. Okay. So Emma, I'll have you look through the slides on lesson 3.
Mm-hmm.
There's a kind of a tricky higher order function example here near the end of the slides. I want you to work through that on your own time and see if you can kind of get comfortable with that. And I think you'll see that there's a lot of power there. Okay?
Okay.
Cool. And so yeah, so lesson 3 was all about the adventure game. Make sure you can get that running. If you have trouble, you let me know. Bonus assignment for lesson 3 was this airport data problem. Lots of fun. Again, if you have trouble, you let me know. Okay? Great. So let's jump back into lesson 4. So we are going to, last week we made our first game, an adventure game. This week we're going to make Pong, which is our first real-time graphical game. And so the rules of the game are going to be, the things we need to learn to implement a game are going to be a little bit different this time around, but hopefully different in an exciting way. So again, we already recapped lesson 3. Once again, there's a link to the site materials, the course materials. And then goal for the day, we're going to learn how to write our game of Pong. And I showed a version of Pong during the last class, but I ended up simplifying our Pong code significantly since then. So I'm just going to show you guys what the Pong that we're going to work on today looks like, at least the one that I've ready for you guys. So we run it, and we should see it pop up on my screen any moment. My computer running a little bit slowly when I'm doing video streaming. All right, so there it is. We've got this Pokeball running around, and we've got a purple paddle for the player, and we've got a green paddle for the computer. And the basic idea is that I can move up and down and kind of hit this ball back and forth. It's a little bit glitchy, but this teaches us the basic concept of game development, of what we need to do in order to get up and running with graphical games. And then in the background, there was a bunch of debug output. I thought about turning this off for you guys, but I thought actually it might be interesting to keep it running. Essentially, when you make a real-time game, your code needs to run pretty fast. And I had this code printing out every time I was rendering a frame to the screen. So we're going to learn how to make a high frame rate game today using Python. So I know that you guys have definitely played your fair share of video games in the past. So this will be an opportunity to kind of peek under the covers and see how it's made. So the different skills we'll need to learn for today are these 5 things. And it may look like a lot, but I would argue that they're all simple. The exception being the second one. This idea of class may take a little getting used to. I think all the other things will just kind of snap together for you guys. So just a quick overview of what these are. Cocos 2D, this is a open source game engine that we'll be using. Andre, you want to tell us what a game engine is?
I don't really know.
Don't really know. Emma, can you tell us what a game engine is?
A game engine is some type of program that runs a game. That could be any number of things, from something that's like well, I suppose you could say that the Python script that runs the adventure game is a type of game engine, and it could range all the way from there to something as complex as Doom, to something as complex as contemporary 3D games with physics engines and things like that.
That's exactly right. So you can think of a game engine as the core code that implements like physics and input and things like that, but doesn't include all the things like the 3D models and the sounds and the textures. You can think of it as kind of like the core code that runs everything. And it turns out that a lot of that kind of code is actually shared between games. So many modern games actually don't build their own engines anymore. I think Blizzard is one of the few studios that really insists on building their own engine for every game. And they didn't even do so for Hearthstone, actually. They're using a Unity game engine, a off-the-shelf game engine for Hearthstone. And Cocos 2D, this is an open source, a free and open source game engine that we're able to use. And we'll see later that this is actually a fairly widely used game engine in the real world. So if you guys really enjoy making Pong, and you really like making games, you might be able to go on and use the same skill set to make other games in the future. Class self. So have you guys ever heard of object-oriented programming? Yeah?
Yes, but I don't know how to distinguish it from other, like procedure-oriented programming?
Yeah, so there's a few different disciplines, but yeah, I would say that most people will talk about procedural programming and object-oriented programming. Nerds like myself enjoy something called functional programming, which is another kind of paradigm of programming. Andre, are you familiar with this idea of object-oriented programming at all?
I have no clue.
No clue. So the basic idea is that so far we've learned about how to use functions or procedures to structure our code. But this idea of objects is basically like, what if we could treat our world as like different types, right? If we could have these little units which have some sort of data and some behavior. Like maybe we have a ball that knows how to move itself, for example, or a car that has a decelerate function, a braking function that's attached to it. So that may be a little bit abstract, but essentially it's a worldview. It's not inherently different from the way we've been doing things so far, but we'll kind of explore this other tool for organizing our code. XY, oh, and by the way, this is the dominant paradigm in industry. If you ever get a job as a programmer, if you ever have to use someone else's code, probably you should be familiar. Well, you'll probably have to be familiar with object-oriented programming to make the most of it. So just an example from our one-on-one studies outside of class, the Twitch API code is built in an object-oriented manner. We can look at that a little bit later. So if we look at XY coordinates, this is going to be really quick and easy. I just wanted to show you guys the different ways of mapping like a Cartesian plane to the screen. Different game systems use that differently. Game loop. This is the idea of how to structure your code to build a very snappy and responsive game engine. There's kind of been a lot of thinking done over game loop design over the years, to kind of touch on that. And then collision detection. Since we'll be building the game of Pong today, Pong is all about this interaction between a paddle and a ball, or a ball and the wall. And we want to understand when those two things are colliding and how to handle that, how to react to that. So we're going to speak a little bit about collision detection today. Great. Any quick questions now before we dive in? No? All right. So Cocos 2D, this is the game engine we'll be using. I just pulled some random screenshots from games that are using Cocos 2D in the wild. Looks like Angry Birds, not the original Angry Birds, but a puzzle game spin-off is using it. There's a One Piece game out there that's using it. Apparently a Family Guy game. And then the list goes on and on and on and on and on. So it looks like there's a lot of mobile games these days that are using Cocos 2D. So I think that this, again, it's not always great to kind of just do what everyone else is doing, but at the same time, it can be reassuring to know that the tool you're using is, it's not just made by one guy in his basement, right? It's kind of trusted by these guys who are actually making money from the product. That's nice to have. And also, it also gives you a sense of what the game engine might be particularly well suited for. So, for example, if we look at what Unity game engine or maybe Unreal game engine is being used for, we might find that Unreal is not being used to make a puzzle game on mobile, and we're making a puzzle game on mobile. So like it can be kind of a nice hint for us to know what the sweet spot of the engine is. And I think that generally speaking, a shooter engine probably works best for a shooter, but sometimes can be used in other contexts. Again, this is apart from our lecture here, but the recent XCOM remake from 2012 actually uses the Unreal Engine, despite it being more of a strategy game than a shooter game. So anyway, just a little bit about game engines there. So what is a game engine? So if we look at what a game engine offers us, essentially the idea is that I'm supposed to do this as a build actually, so you can see it piece by piece, but I neglected that. First and foremost, most people know a game engine for the graphics, right? You say, oh, it's running on the Quake engine, it's running on the Doom engine, it's running on Cry engine. This is often the piece that, at least in 3D games, is kind of the most sought after, because to do 3D graphics on your own is kind of a pain in the butt. So if we're doing 3D graphics, we'll definitely lean on game engine. 2D graphics, it's kind of less vital, but still helpful, right? Because we can render our graphics in a cross-platform way, rather than using something like DirectX graphics, which only work on Windows. Maybe we can lean on our game engine to do cross-platform graphics, for example. Input handling. So far in Python, we've learned how to collect text input from the user. Like input. What number are you thinking of? Or was it greater or lesser? We know how to do that kind of input, but we don't really know how to collect mouse input. How do I collect a scroll up event? Or how do I detect a gamepad? Pi hook. I'm not familiar with pi hook. Well, what is that, Emma?
I haven't actually used it, but I understand it's a way of linking a number of built-in Windows functions with Python.
Okay, yep.
I'm not sure.
Yeah, so I'd have to look into that, but it sounds like it's a bit of Python code to call into the Windows we call it API, and to call into the kind
Hmm.
of the core Windows operating system functions. So yeah, you could in that case you could probably use PyHook to do that kind of thing. And again, what's nice about a game engine again is that I think this is a big driver is that often it's done in a cross-platform way, so that PyHook I imagine again based on what I'm hearing is Windows specific. But if we use Cocos 2D for example, we can get the mouse input, we can get the gamepad input, we can move that between Windows and Mac. There's even a version of Cocos that will run on iPhone and Android and all that. So portability again, input handling is nice. Networking, doing your own like real-time game, whether it's StarCraft or Counter-Strike or one of those, it can be a major pain in the butt to figure out how to keep different players in sync across the internet. And often a game engine has some core code to help us manage that. Physics is a big one, as you guys have mentioned. These days, games are getting increasingly realistic, and having a nice physics simulation built in is often a role of the engine. And I've mentioned cross-platform a couple times. I think that that's a major selling point if you're going to distribute a game, on Mac or like PS3 and Xbox. So these are the different benefits that a game engine can give us as we make our game. And this step right here, pip install Cocos 2D. This is the first time that we're going to have you install third-party code in your studies. And this command right here, pip, this is for installing third-party libraries. In this case, Cocos 2D is an open source package that lives out there on the web, and we need to tell pip to go out and install it on our computer. So use this command when it's time for you to install your Cocos. Okay, let me close one window. Sorry, guys. So here, this is our first exposure to the idea of class and object-oriented programming. And I've typed up some more examples in a text file that we can look at in a second. But completely cold, I'm actually just going to ask Andre actually just to look at this code that's in front of me here and take a guess at what it's saying. Andre, you there?
Yeah, I'm here. Sorry.
Yeah, sure.
I'm thinking about it.
Sure. Okay. So Emma, look it over in the meantime. Come to your own thoughts. We'll hear Andre first.
All right, so it's giving the start point and the start velocity of the game. I assume it's going to be the game that is the UFO. So like, do you want me to talk about like what I think the game is doing based on what this is?
Sure. I mean, let's hear all your thoughts because again,
Sure.
this is just an exercise. Yeah.
This seems like that helicopter game almost, where it's like you're going up and down and you're trying to dodge obstructions.
Sure.
And then start point is your 0, 0, and then you're going at a speed of 75, 25, which there is, it's going to be an XY plane. So I assume you're going 75, a unit of 75 measurements forward and 25 up or down.
Great. That's a great answer. And then, do you have any thoughts about what I guess what init and what class mean here? Like, does that make any sense? Is that completely abstract?
Oh, you already told me.
Oh, did I?
Yeah.
All right. Hey Emma, how about you? Class and init. What do you think about these guys?
Well, so I haven't gotten this in my studies at all, but I'm guessing that we're defining some class of object, which is an unidentified flying object, and then like the initial values of that.
Yes, that's right. So we're gonna take a quick look at this, where where indeed we are defining this type of thing called a UFO, and we're saying in it we're essentially saying when you make a UFO, here's what you do. You're going to set the position to 0, 0, 0, set the velocity to 725. So every time you make a little baby UFO, they're all going to come out of the mothership, so to speak. They're going to come into existence with the position of 0, 0, and velocity 725. And so just to exercise that a little bit, you can see, we can come back to this one in a second. But you can see, actually here's a question. If we just run lines 1 and 2 right here, guys, I want to ask you a question. Are my UFO and Russian UFO, are these the same thing, or are they different things?
They're the same.
Why are they the same, Andre?
Because they're equal to UFO, and UFO is going to spit out 007525.
Okay, so because of position 0, 0 and speed and velocity 725, they are the same. And what do you think? Are they the same or are they different?
They look to be the same. So from where I stand, it looks like they're both variables that refer to class of objects that we define with UFO. They're about to be different in terms of position. But I don't know. It could be that there's like two objects. I don't know.
Right. It could be that there's two objects. So I want to point something out to you guys. So check this out. You see this little difference between line 2 and 3? Line 3, we don't have the parens. So what might I be talking about in line 3 versus line 2? There's a hint.
Instance versus the whole class.
Exactly. That's exactly right. An instance versus the whole class. So what I want to point out to you, is that if you look at line 1 and 2, when we put the parens afterward, it's just like when we make a function. Like if we say square of x, return x times x, we say square of 5, we know that we're running the function square with parameter 5, right? And so if we look up here at UFO, what we're learning right now is that, again, if we've got a class UFO, and what do we say? Init self at position equal to 0, 0. Velocity is 2575, or 725. So we know that when we run this open and close, that we're going to create a baby UFO. We're going to create a new UFO. But when we run it without, exactly, we're not running any code. We're just saying, hey, I'm talking about this class UFO. So it's almost like this like if we said over here UFO class, boom, then now we'd be making a UFO. We'd say third UFO equal to that. You guys following me so far?
Okay.
Andre, how's that feel?
Doesn't feel good.
Doesn't feel good. Feels weird, right?
Doesn't feel right. Yeah.
Okay, so I'm
So
gonna make it feel.
What's the difference between line 8 and line 9?
Okay, so on line 8, we got a reference to this class UFO, this thing. And then on line 8 and 9, is that what we said?
Yeah, 8 and 9.
8 and 9, okay, sorry, it became like 9 and 10 after I moved it. So now it's 9 and 10, right?
Yeah.
Yeah, okay, so basically, it's like we're doing this in two parts, right? Where you say something like, here's an equivalent. If we go down to like line 15, on line 14 we say square of 5. On line 15 we say f is equal to square. Give me f of 5. You see this progression here, 14, 15, 16?
Yeah, I do. Okay, that makes sense.
That makes sense, right? So if we come back up to, let's say, line 7 versus line 10, can you see how this is analogous?
Yeah.
Yeah? It's just a little funny, though. It's a little weird, right? Okay, so yeah, so the next thing I want to go over is this idea of, are these the same or are they not? Is my UFO the same as Russian UFO? And I've heard like two conflicting ideas. I heard one idea, well, they've got to be the same because they got the same position and they got the same velocity. And then the argument is like, well, they've got the same position and same velocity, but they're different things. And and here's an example I used in the live class today that I thought helped explain this. Where let's say we have a Barbie doll, and every Barbie doll, when we make it at the factory, we say, hey, guess what, Barbie? Your name's Barbie. And then you can have my Barbie that I went to the store and I proudly bought. It's a Barbie. And then your Barbie, well, guess what? These things both came out of the same Chinese assembly line. They're both completely identical, but one's mine and one's yours. Does that make sense, guys?
Okay.
How do you feel about that?
That's fine.
It's like they're like identical copies of each other, so to speak.
Two objects have different names, basically.
Well, in this case, it's not names, but you're right. They're like in Python. There's going to be some sort of ID number, and we can actually play out this Barbie example right now and have some fun with it. So if I run it right now, if I open up my Python interactive prompt, see I've got I got the Barbie class that I made, and I got my Barbie, your Barbie. So my Barbie, your Barbie. You'll notice that these are all exactly the same. I could say my Barbie.name, your Barbie.name. It's all Barbie. But wait a minute, this funny thing is different. Have you guys ever seen something like this before?
Oh, that's someplace in memory?
Emma, you said is that someplace in memory? Is that what you said?
Memory?
Sorry, you're breaking up a little bit. Someplace in memory, yeah? Yeah, that's
Is it?
exactly right. That's exactly right. This is
Oh.
a memory address, right? So it's basically, it says, okay, so far they seem to be exactly the same, except this place that they live in is different. So again, this might be a little bit abstract if you guys aren't as familiar with how memory works, but you can think of the memory of your computer as just this long line of buckets, right? Each bucket can hold like one tiny little number in it at a time, one byte, one 8-bit number at a time. And when we create a Barbie up here, Python goes and finds an idle bucket where we can go put Barbie in. And you're right. So basically, guys, like in a way, both answers are right. Like if you compare the value of the object, you're right. They both contain the exact same data. It's just named Barbie. Or like back with the UFO example, well, guess what? They both have position 0, 0. They both have velocity 7525. But at the end of the day, they're different because we're actually tracking their data in different places in memory. And if I, for example, I could say my Barbie, we're going to change its name to Ken. And so my Barbie is now, my Barbie.name is now Ken, but your Barbie.name is still Barbie. You guys with me on that?
Can you scroll up just a little bit so I can see the syntax for defining Barbies?
Okay, yeah.
Okay.
Andre, have any questions on that?
Nope.
You sure?
Seems good.
How uncomfortable is it?
I'm very comfortable with this.
Very comfortable? Great. Awesome, man. That's great. Because I know when I learned this for the first time, it didn't make a lot of sense to me. I was like, what? Emma, how are you? Good to move on, or?
I think so.
Okay.
I just want to say the only reason I knew the memory thing is because I've seen that when video games crash and they say error at this location.
Yes. Yes, that's right. That's exactly right. It's the same thing. It's the same thing. You're like, Counter-Strike crashes and like, what? All right. Awesome. So that's class and self. And something that I want to point out to you guys is that we've seen before this idea of anytime you have an equal sign, you're creating a variable on the left, right? You're either assigning to something exists, and if it doesn't exist, you're making a new one. And what's interesting is that this also applies to an object, right? So when you're creating an object in init, feel free to go hog wild and create a bunch of different, we call them properties in there. You have a lot of power. And one student asked, does it matter that we call it position? Does it matter that we call it A or X or Z? And I said, no, you can call this whatever you want. It's just a way, you have to be consistent with your own program, right? It's kind of a human way of dealing with a concept. Let's give it a name position. Let's always call it position, and we'll always be able to find it in every UFO. We'll just have the position right there. Right on. So properties, this is the name for these variables that live inside of a class or live inside of an object, technically. So I just wanted to kind of just take one more look at this. This is actually some real code that we'll be using in our Pong game. Have you guys heard of a sprite, by the way? What's a sprite, Emma?
It's basically just a 2D image.
Okay. Yeah, it's a 2D image, and it's classically used. I mean, the reason it's useful is so we can draw this 2D image on top of some other 2D image. Right, like when we're doing Mario, we don't want to blend Mario in with the background. We want to make sure he's always drawn on top of the background. So a sprite-oriented style is what most 2D games have used, all the way up until the modern day. Right up through 3D gaming, everything tends to be, well, most things tend to be sprite-based. And so yeah, so same kind of stuff, position and velocity, just like the UFO. But you notice now we're talking about the paddle from before. And actually, one other thing I wanna point out to you guys, and this might be a little bit strange, is that in the sprite, which is something that Cocos has, and we'll be using Cocos' code for, sprite already has a position. But a velocity is an idea that I decided to make up for our Pong game, because it's actually easier to model the game. The paddle and the ball have a velocity. So I just want to highlight this. This may not stand out right away, but if you wanted to, you could just make up a new property, a new variable, on top of an object at any time. You could just say like, hey, paddle dot, I don't know, dot trouser size equal to 32. You could just make up something right here and use that. So Python is very flexible in that way. Languages like Java will not allow you to do that. Languages like Java will make sure that when you define that class, that you made sure that trouser size or whatever maximum occupancy is defined here inside the class definition. But Python is kind of a very loose kind of language. It likes to shoot from the hip, and so this idea of velocity, I decided, hey, you know what? Sprite already knows about position. It would be useful for it to know about velocity. I'm just going to put it in there. Do you follow? Any questions on that, Andre, Emma?
We're good.
Good.
I think so.
Yeah.
I've been
okay.
Okay. So you can set that position of paddle like that, and then you can recall it by saying paddle.velocity.
Yep, that's right. That's right. Cool.
What does the self do?
Great question. Great question. So I'm going to come back a page. I'm going to have you guess what self might mean.
Because I've been playing with UFOs in the PowerShell.
Okay.
And so I have Russian UFO, which has, it would be like velocity dot Russian, sorry. Russian UFO dot velocity 2525, because it has the same velocity that was set insertional strings, but I made John's.ufo, or John's UFO, and you can say John's UFO velocity equals 66,66, and then John's UFO velocity queries that, and you get back 6666. So
That sounds about right. What's that?
What's the self do?
What's the self do? Okay. So self is basically, it's a first-person variable or a first-person reference. Self is I. So if you look at this code here, init self, self refers to the object that's being created when we run init, right? So if we come back and look at the text editor, like in here, when we run Barbie open close, for example, then it'll run this init function to help create a Barbie. This is kind of like the process of making a new Barbie, making a new UFO. So in this case, self refers to this new Barbie that's being made right now. We're going to go into that object. We're going to set the name to Barbie. Same thing, if we're making a new UFO, we're going to set the position of self, which is this new UFO, to 0, 0.
Okay.
Right?
So can you swap self when you're defining a class of objects, can you set so you say define Barbie def init thing, and then in the next line use thing.name equals Barbie?
Yes, that should work, but that's frowned upon. I mean, we can try it right now. Let's try it right now. We'll say thing, and we'll copy it, and it should work. Yeah, so it worked, but again, the convention is self. Everyone uses self. I recommend use self. But yeah, again, that is a nice thing to know.
Okay, it makes it clear that it's an object.
Yeah, exactly. Just like any other thing, just like X, just like Y. Yeah. Okay, great. So yeah, that comes in.
I have a question now.
Good thing, Matt.
You're running the program within itself underneath the class.
You're talking about over here?
So yes. So you have class Barbie, def init, yada yada yada. A lot of times I just see class Barbie def init thing dot or self dot name equals Barbie, right?
Mm-hmm.
I have to call the class before I am able to do, Barbie parent. Is that right?
Okay, so you're saying you have to call the class before you can instantiate it? Oh, sorry,
I have this class Barbie, okay, and that's called Barbie.py.
Yeah.
And then
okay.
I make a new program called toy.
Yes. So exactly. So you need to do what we call importing. So I can. I'm going to make a folder called Barbie, and I'll just illustrate what you're talking about. So let me move my face out of the way. Here we go. So if we have Barbie.py and maybe, I don't know, toy.py, I think you said, or toys.py. So if we go into Barbie.py, then in here, I'll just paste in the old Barbie code we had. Wait, that's here. Okay, so here's Barbie.py, and then I'll lower my face again. Okay, and then we'll open up toy.py, and then we need to say import Barbie. And then here's the confusing thing. Right now, it would be Barbie.Barbie. Does this make sense at all so far, Andre? Or what's
Yes. Yes, it does. So, as soon as I have a single Python code, I can import it from wherever it is in my computer. Does it have to be the same folder?
So that's a great question. So by default, Python will know how to import files from a central location where you install, like, when we did pip install, when we did pip install Cocos2D, that goes out and downloads Cocos2D to a central place in your computer. So Python by default knows how to pull stuff from this kind of idea of like I'll call it like a central library directory. I'll just call it for now. And then it also knows how to pull from the present directory. So if you wanted to do some random directory, you would need to teach Python where to find those files, or tell Python where to find those files. Does that make sense?
Yes.
So yeah, so there's some configuration you would need to do if, like, let's say, I don't know, in your case you like to work on video stuff, so maybe you wrote a utility for drawing 3D graphics on top of a video stream, right? And you're like, oh man, this is sick. Anytime I need to draw 3D graphics, I'll use this code. If that code is only living on your computer, then you would either want to move that into that central library directory, or you'd want to copy it in to everywhere you need it, or you'd want to change your Python settings so that your 3D code can be pulled into any other video projects that you work on.
Okay.
Good to go?
Yep.
Cool. Yeah, also, one thing I will say, many people, in the case, yeah, Malibu Barbie, nice. Many people will, many people will say, Emma's having too much fun with Barbie over there in the chat. Many people, if your code is not like proprietary, like if you're open to sharing it with the world, then an easy thing to do might be to just upload it publicly on the internet. Just because, for example, pip is a really nice tool, and if you've got multiple developers on a team, it can be easier to say, hey man, just run pip install, and you can get my code. So we can talk more about that later, but I would say when you're working as a solo guy, probably one of these two things is a better option. But as you work on a team, you might want to consider doing more of a central library type of approach.
Okay, that's so cool.
All right. Any other questions on Barbie and objects and things like that? Okay, got it. It's pretty funny that we ended up using Barbie as our example, but I thought it made sense. All right. All right. So we spoke about this already. XY coordinates. So this might seem like a really pointless slide, but I want to point out to you that in Cocos 2D, the bottom left of your screen is going to be 0, 0. The top right of your screen is, well, it's going to be something, something. In our case, I gave you guys a scaffolding, like a template for doing the Pong game, and that template right now has a screen size of 600 width, 600 height. So right now you'll know the top right corner is 600, 600. You're free to change that if you want to, but this is a nice starting point, because then you know that 300, 300 is always going to be the middle. And if you're having any weird errors, you might be able to use that. Say, hey, this ball is behaving weirdly. Let me try moving it in my code to 300, 300 and see if that's the middle. And if it's not the middle, then maybe something bad is going on. Questions on this so far? No? Okay, so quick thing. I mentioned this because many other game development systems actually put 0, 0 in the top left corner. And I believe the reason for that is that like everything in computers tends to go left to right, top to bottom, just like the English language. So I believe what happened was someone just called this pixel 1 or pixel 0 in the very, very corner of the screen. And then because of that, this becomes row 1, 2, 3, 4, 5, and suddenly, you know, the y-axis is backwards from what you normally expect. So that's just kind of a funny little historical thing. All right. Again, by this time you guys should be very comfortable with this, but if you wanted to set the ball to position 0, 0, that's how you do it. Pretty simple. And again, just a reminder, position is something not that we made up, but this is something that Cocos actually knows about. So if you ever go to any other Cocos project in the future and write a game, you'll be able to use position to move things around. Game loop. So I've got a great joke for you. So why did the programmer spend so long in the shower? Anyone? Emma?
Because the shampoo bottle said lather, rinse, repeat forever.
Exactly. So kind of, yeah, programmer humor. We take things very literally. Our work takes us very literally. Lather, rinse, repeat, lather, rinse, repeat, lather, rinse, repeat. But the real reason that I bring this up is that a game loop is a very repetitive thing. Basically, a game loop is, yeah, wall shampoo is, yeah, that's true. a game loop usually has to run at about 60 frames a second these days in order for the game to appear smooth, right? We know that film runs at 24 frames a second. TV used to run for a long time at 30 frames a second. Most games these days run at 60 frames, and if it's less than that, the user will often perceive stuttering or slowness, and so it's really important for us to design a really high-performance type loop. I know Andre is very interested in doing programming for broadcasts, and that's the same kind of issue. It's like how do you make sure you've got a nice tight loop, you're doing the right things, and you're rendering those frames out so your users all just enjoy a nice, smooth experience. So we're going to look at the fundamentals of building a nice game loop today. So the three main components of a game loop are, first, you check for user input. You know, have they pressed a button? Have they moved the mouse? You know, are they dancing on their Wii Fit board? You know, but whatever kind of user input you're doing, you want to usually look for that first. Based on any input, you want to change the game state. You know, in a tic-tac-toe game, that might be to put an X in the grid. In a Pong game, that might be to change the position value of the paddle. You know, in StarCraft, that might be to mark, you know, decrease hit points of a Zergling by 6. And then at the end, based on this new game state, we're going to take this game state and draw it onto the screen. And again, in a game like tic-tac-toe or Pong, that might be very simple. In a game like Call of Duty, that's going to be a much more involved process involving you know, linear algebra, graphics cards, things like that. But this at the end of the day, no matter whether you're making Pong or Mario or Call of Duty, the fundamentals are all the same. And again, I think you'll see similarities in broadcast systems as well. So user input during game development, these days we have an amazing array of input devices. It used to be, you know, PC was just keyboard and mouse, consoles were just controllers, but now we're seeing more and more touch devices and motion control and things like that. And what's cool is that all of these we essentially handle in the same way. We don't have to categorically treat these as different things. Nice. And Cocos actually gives us good tools for dealing with these. So something I want to point out is that in Cocos, when we want to deal with a key press, we can actually get notified by Cocos that there was a key that was pressed. And in this case, we get this key, and this key comes in as a big, ugly integer, this big, ugly number. And I looked up some of the key codes for you guys. So this 65362 is actually the up arrow. And there are some ways to use, like, to put lipstick on a pig and to, like, give this a better name. But I thought it was actually more educational for you guys to let you know that the computer is actually just sending up these crazy numbers and saying, yep, that's the up arrow, and down arrow is like 65363 or something like that. And the idea being that you can then run some code in response to a button that the user has pressed. Good? Yeah?
Good.
So something that I want to point out to you guys, and this might be a little bit abstract right now, but I keep emphasizing this idea of this type game loop, you know, input, game state, draw, input, game state, draw, blah, 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 blah. And in the good old days, everyone would actually write that core loop very literally and very close to the metal, like very raw. But these days, many people are trying to write at higher and higher levels of abstraction and realizing that, you know what, rather than being a performance freak and like really writing all the low-level stuff, maybe I can offload the game loop to the engine a little bit, and I can maybe worry a little bit less about those details and worry about bigger things, or about more abstract things. And so this idea right here, on key press, this is an example of something that's higher level than in the past. In the past, the way you do it is you wouldn't be told. Right here, we're being told when a key is pressed. In the past, what you'd say is get me the keyboard object, look at all the keys, see if any of the keys are currently depressed. Right? And so you can think of one as like the old model is more about pulling the data, the new model is more about pushing the data. It turns out that pushing the data is often less performant, but more convenient. So anyway, maybe that was too much detail, but I just want to let you know this is a really nice way of dealing with user input, and you'll see the same patterns on key press idea. You'll see this if you write for Android, for iPhone, for Windows, for the web. It's basically everywhere these days. This style of handling input. So that's cool. Update the game state. So if you aren't able to update the game state, nothing interesting can happen, right? Like Mario can't jump, can't run, Pong paddle can't move, ball can't move. Updating the game state is how we actually change what's happening in the game world. And again, this is like a super simplified example, but we can see very clearly here that in Mario, if we hit the jump button, we're expecting the position of Mario to change. And I additionally have this Boolean idea of whether he's jumping or not. And I guess the idea I was going for there is like whether to draw Mario in like the jumping stance or whether to show him in the standing stance. But again, this part of the game, in my mind, is the most important because this is what gives the game gameplay. It gives it life. And unfortunately, this is also the thing that's most application specific. Like you can't just you can't just borrow someone else's game state management completely from another engine because your game is probably most different in terms of the gameplay. Do you know what I mean? So this is probably the point where you're going to be able to differentiate your game most from the competition. Drawing to the screen. This also a fun step. Generally speaking, what we're trying to do is we're trying to go from this kind of programmer-friendly representation of the game world into a nice graphical representation that a user can appreciate. So, like for example, if we're doing a tic-tac-toe game, a programmer, I'd be very happy to represent a tic-tac-toe game as a list of lists of O's and X's, right? And we can just kind of, if someone makes a move, we put an O in here. Maybe these strings are blank by default. Maybe it starts out like that, and then we put an X in there. And this is great to work with, but this is like the worst user interface ever, right? If we ask our user to click in here and change the O, the blank thing to an O, then that's a huge pain in the butt. So I just wanted to highlight how with programming, we're often under the covers, we're using something sneaky like this to represent the game, but then we show the user this like beautiful veneer on the outside, saying, "Wow, it's such a nice game. It has such life to it." But we're really kind of breathing the life into the code, into the data. So yeah, and in terms of Cocos 2D, what you'll find is that they do a lot of nice stuff for us. So drawing to the screen, we don't have to worry about it. We just kind of define some sprites. We define like the ball and the paddles, for example, for Pong, and we say here's where they are on the screen, and then Cocos 2D just takes care of drawing them. Great. Pardon me. Then handling the user input, as we saw earlier, they have this really nice, on key press, on mouse move, that kind of thing. So it's actually really nice to work with the user input as well. Unfortunately, though, of course, this game state, this is highly manual. So we're not getting too much help from Cocos in terms of managing how our game world actually works and how it's stored and how it runs. But hey, I mean, programmers have to have some work to do, right? So any questions on this game loop stuff so far, guys?
Makes sense.
Good. Okay.
Sense.
So what's that, Emma?
Makes sense.
Yeah. Okay. So last thing for today's lesson: collision detection. Basic question asked by collision detection is: Are these two objects touching? Are they colliding? And this. Oh, pardon me. Oh, I don't know what's coming over you. This comes up all over in game development. It comes up in Pong very clearly, because Pong is all about collision detection. It's about, is this ball hitting the wall? Is it flying off the screen into one of the goals? Is it hitting the paddle and bouncing off? This shows up in shooter games, right? Like, can you walk through a wall? Well, maybe if you turn on no-clip mode, right? And no-clip mode is literally turning off the collision detection. And StarCraft, right? As we know, the original game is highly reliant on unit collision and being able to body block people. So this is something that comes up all over game development. And some tips for implementing your collision detection inside your game. Oh, by the way, I will say this. Many game engines actually do have collision detection built in, and you can just enable their module collision detection. For this week's assignment for building Pong, I am asking you to not use the built-in collision detection and try and implement your own, because the Pong game is actually fairly simple, and actually you can build a better, like a funner collision detection for Pong than what you'll get out of the box from one of these existing solutions. So for this week, let's try and build our own collision detection. I think you'll find it pretty easy, but challenging enough. And the key ideas are basically, is part of A inside of B? Is part of B inside of A? If you can solve these two, you can basically solve collision detection. And then the kind of counter to that, are they not colliding at all? So you can think a little bit about how you might implement that in your code using things like position, using size might be another thing. And I've got a hint for you. It's easier if you look at one axis at a time. And again, you don't have to retain all this in your brain right this second, because I do actually have a scaffold project for you. And we could take a quick little peek at that guy. In the homework, let's see if I can open it up. Yeah, so if we open up this file will be given to you as part of your assignment. You'll notice that I import Cocos, the library, at the top of the file. And I set some of these constants here, time per frame, well, it's 1 second divided by 60 frames. And so maybe I can change that to be 60 frames a second. But anyway, there's our min-x, max-x. This is our idea of a 600 by 600 playing area. The ball size, the paddle size, initial ball velocity. And then I have basically these stub functions for you guys, saying like, hey, is A colliding with B? And I suggest you may want to do this idea of axis overlapping first. That way you can kind of check if the x-axis is overlapping and then check the y-axis. Because I find if you do both on top of each other, it's kind of like a huge mess. Likewise, you'll see that. Oh, actually, I should show you. If we run the code, as is right now, you'll find that we see paddles, but the ball just kind of flies off the screen. So it's kind of entertaining to look at that. Okay, we're not in Barbie. We have homework. So if we Pong.py. Give it a second. Yeah, and again, super rudimentary thing, but I wanted this to be a nice starting point, so you guys wouldn't have to fuss too much with the tools and be able to focus more on the learning. So yeah, so when the game starts up, you'll see this goofy little game. Oh, it doesn't even handle the ball flying off the screen just yet. Let me do that one more time. So run it again, and it should load a little faster this time. Again, I gotta upgrade my PC. Thing runs a little bit slow when I'm streaming and teaching at the same time. Patience is a virtue. Here we go.
And PowerShell.
So, yeah, so there we go. So we got the Pokeball running off the screen. We got these paddles. I should be able to. Oh no, I'm not able to move it. Oh. So anyway, so as you see, there's a lot of work to be done. You gotta. I think I wrote some to-dos in the file. Let's see here. If we go back. Oh, that's the turtle thing. Homework. Pong. Yeah, so you should be able to see these to-do places. Make the ball bounce off of the top-bottom boundaries. Make the ball bounce off each paddle. The player runs off the left side of the screen. Reset the ball's position. Make the computer's paddle move towards the ball. So I tried to be more structured in this week's work because I think it may be trickier for you guys than some of our past assignments. So that's what's going on with that. And then I think, yeah, now we're at the recap. We learned a little bit about game engines, and the game engine we'll be using today, Cocos 2D. We spent some time learning this idea about class and kind of defining our own data types in our program, and what is self, what does that mean? We learned a little bit about XY coordinates and how bottom left is 0, 0 in this system, but there are many systems out there that top left is 0, 0. We learned essentials of doing a game loop for making a high-performance game and how to apply that to our own Pong game. And we learned kind of just a quick taste of collision detection, which is going to be a lot of the focus of the homework this week. So any questions on what we learned today before we just kind of go through the homework assignments? No? Good. So, again, get that Pong game working. I'm sure you can do it. Send it to me when you've done. And then I've got 2 rounds of bonuses this week. Because I think this one, for the determined visual, I think that'll come together pretty soundly. And so, bonus A, show each player's score on the game screen as they're playing. Second part of that challenge, change the paddle code so it's more interesting. You'll find right now that when you hit the ball with the paddle, it always bounces in the same way, and it makes the game very bland. So if you play a little bit with the paddle bounce, maybe you make it random where the ball goes. Maybe it's based on where on the paddle you hit. If you hit very near the edge, maybe it flies in that direction. Hit in the center, maybe it doesn't change that much. Right? I want you to play a little bit with how the paddle collision happens, because I think that makes the game a lot more fun. And then the final thing, if you guys completed all of that and you're still hungry for more, I want you to try and make a game of Breakout. And for those of you who don't know the game of Breakout, this is what it looks like. You've got a paddle on the bottom of the screen, you've got a ball that moves up and down, and you're trying to break all the bricks. So again, it might seem ambitious, but as you can see, this uses all the same tools that you'll need to build a Pong game. You've got a paddle, you've got a ball, you got something for the ball to collide into. The only thing is that you're introducing this idea of a brick that can destroy itself, that can go away. So I think this is pretty cool. I think this is a classic game that many of us have spent a lot of time on. So sweet. That's your bonus assignment. And then next week we're going to come back for fractals. And I had some trouble running my example on my Mac today. So I'm going to have to just show you quickly someone else's fractal as opposed to my own fractal. But we're going to come back next week and learn how to draw the Sierpinski triangle. Now, first I'm going to show you the Sierpinski triangle, and then I'm going to tell you why it's awesome. So, yeah, here it comes. Well, I guess I'll tell you. Yeah, so essentially, the reason that fractals are interesting is that fractals are defined in a recursive nature. That is, they're kind of self-similar. We kind of tell the object, in order to make the next level of yourself, you need to look at the previous version of yourself. And this idea of recursion describes many, many natural systems. And I would argue that we've already learned looping, and that is one of the main ways that programmers solve problems. And I would argue that recursion is the other main way that programmers will attack a problem. So I think once you have mastered recursion, you really have been exposed to all the key techniques of problem solving. And my computer is taking forever to load, so I think I won't belabor this too much longer. Here we go. Yes. This one right here is good. Oh man, it's painful to watch this load. But yeah, well, conceptually though, guys, we start with one large triangle. We take that triangle and we split it into 3 smaller triangles by drawing a white one in the middle. And then we take those triangles and we split those into 3 smaller triangles. And then we take those and we split those into 3 small triangles. And so you go on and on and on and on towards infinity. And this might be one of the simpler fractals out there, but there are some fractals out there that are completely mind-blowingly cool. And we're going to learn how to draw this next week using recursion and Python. Awesome. So anything else we should go over as we're winding down, guys?
I feel
Andre,
good.
how you doing? Feel good, man?
Yep.
Anything to go over? No?
No, I feel good about it. I'm actually looking
Great,
forward.
man. Cool. Looking forward to Pong, looking forward to triangles, all the above?
Yes, sir.
Good, man. Emma, how about yourself?
I feel good. I feel very. I feel guilty about falling behind in terms of Python. But I think all the concepts we talked about today, I feel good about. I feel like your way of delivering the concepts is really good.
Great, thank you.
There's not a lot of. Seems like today's class wasn't super cumulative, so some of the material that I missed wasn't super detrimental to my understanding of what's going on today.
That's right. That's right. Yeah, I think I think the challenge that I've had in this class, or at least basically what I've tried to do, is that by the end of the 7 classes, that you've gotten a taste of like all the different fundamentals. And so you're right. Some of the lessons do build on each other more than the others. I think like the last 2 or 3, I think were more cumulative. I think this one is kind of more of a sidestep, although we're kind of working more on like objects, which is an aspect we haven't really touched upon yet in class. No, I'm really glad that you got a lot out of it, and I'm hoping that you can put the time in, catch back up, and join us next time. Cool.
Awesome. Yeah.
All right, guys. Well, hey,
Yeah.
you know how to reach me. Oh, what's that, Emma?
And I moved, and I'm no longer working at the grocery store, so scheduling works out.
Oh, great. Are you living in Malvern now, or where are you living?
Yeah, just like 15 minutes from work.
Oh, that's terrific. I'm really excited.
Yeah.
Yeah. Andre, just FYI. Oh, do you want to tell Andre what you're working on? Yeah, Andre. Emma, why don't you share with Andre what the life change you're making?
Okay. So as of last Monday, as of this past Monday, the 20th, I'm working as an academic intern with UST Global. UST Global is basically a global tech company that has a lot of different they offer a lot of different services. One of which is basically a training program and it's like a training and recruitment program for different client companies around the U.S. It's called the Step It Up America program, where it is IT, right? It's capitalized. And I'm basically going to spend the next like 4.5 months training in COBOL to eventually work at Vanguard, first for a year as a contractor, and then hopefully, if I do well, if I impress people, and I suppose if I like it, to work as Vanguard staff basically in like the tech financial sector, which is really exciting in terms of building a career, in terms of working for an employer with deep pockets, and the line of the weekends now that I've made the move, rather than driving from South Philadelphia, like somewhere between 45 minutes and 90 minutes, depending on traffic, to and fro, now 60 minutes down the road. What I've been saying is, well, in a very real way, now, like, my life depends on my success in this program.
Yeah, there we go. You're all in on becoming a programmer. So
all in. Yeah.
Yeah, I understand. I can understand if IST cuts into this a little bit, but I think, put it this way, I think that with your improved schedule and with your improved skills in the codes, I think you'll be able to keep up with it. So I look forward to you kicking some butt both in this class and the IST thing. Okay?
Yeah, definitely. Yeah, I'm one reason I'm
you want to thank Andre for that?
Sorry?
Andre gave you his congratulations.
Thank you. Thank you, Andre. So COBOL is, I understand, not object oriented, and it's like I don't know much about COBOL yet. I've only looked a little bit about it, but maybe it's procedure oriented. I'm not sure. So Python is very easy to understand. And the Udacity tutorials, there's this thing that, like, in Python you can fly, and I feel good about learning more of like the fundamentals, and I feel like there's a good complementing thing that can go on here.
Great, excellent. All right, so let's wrap it up there. By the way, Emma, I did mention it earlier, but your microphone's been a little garbled this session, so take a look at that for next time.
Awesome.
And I guess I'll see you guys next week. Okay?
Awesome.
Thanks,
Bye.
TJ.
And much love to you guys. I'll see you. Bye.
Bye.